Welcome to Get Your FRQ On. This question is from the 2006 B exam. It's question 1, and it is calculator active. In the question stem, we have a function f, which is the sum of a polynomial and a trigonometric function, and a tangent line to f at x equals 0, and we have two different regions shaded. A region R, which is to the left of the y-axis, and a region S, which is bounded between this tangent line and the graph of the function f. In part A of the question, we are asked to find the area of this region R. And in order to do that, we need to know the x-intercepts of this function f of x. All right, this is a calculator active question, so we can use our calculator to determine the x-intercepts of this function f of x. So if we do that, we have x-intercepts at negative 1.373122, positive 1.34 and some change, 3.16 and some change. And for this particular question, given the graph in the region R, we're clearly interested in x equals negative 1.373122, and I'm going to call this A for short. So the area of region R is going to equal the integral from a to 0 of f of x dx. And since this is a calculator active question, use your calculator to find this integral. It's about 2.903. In part B of this question, we are asked to find the volume when the region R is rotated around the line y equals 2. So a couple of things here. We are rotating around a horizontal line, so we're going to integrate with respect to x. But there is going to be a carved out area here, so we're going to use the washer method. So we need to come up with two radius functions, a big radius and a small radius. And our big radius is going to be comprised of the curve which is furthest away from the axis of revolution. In this case, that's going to be the graph of f of x. So our big radius function is going to be f of x minus the line we're rotating around, negative 2, which turns out to be plus 2. And our little radius function is going to be comprised of the boundary closest to our axis of revolution, which is just the x-axis, which has equation y equals 0. So our little radius is just going to be 0 minus negative 2, or 2. And if we set this up as a volume integral, we have pi times the integral from a to 0 of our big R function squared minus our little r function squared dx. And again, it's a calculator active question, so let your calculator do this work. That volume is 59.361. In part C of this question, we are asked to write the integral for the area of region S. We do not have to evaluate it, but we do need to write it. And in order to do this, there's a couple of things we have to know. The boundary at the top of S is this tangent line, but no equation for that tangent line is provided. And we don't know where this tangent line ultimately intersects F again to give us our second bound of integration. So we have to figure that out. All right, we have to know, well, if f of x is this function, I need to know the derivative at x equals 0. We are told that the line is the tangent line at x equals 0. So I need to evaluate the derivative at x equals 0, which you can do manually. I show it here. But this is also calculator active, so you could use your calculator to figure out that the derivative at 0 is negative 1/2. We also need to know the value of the function at x equals 0, which turns out to be 3. And then we write the equation for this tangent line. So if f of 0 is 3 and f prime of 0 is negative 1/2, then the tangent line has equation y equals negative 1/2 x plus 3. All right, that's the top boundary. All right, so where is this upper bound of integration going to be? Where do these two graphs intersect again? So I'm going to use my calculator to figure that out as well. The graph of f of x is equal to the graph of negative 1/2 x plus 3 when x is 3.38987. I'm going to call that t for now because I don't want to keep writing out all those numbers. All right, so the area of region S can be found using the integral from 0 to t of the higher of the two functions, which is the tangent line, so negative 1/2 x plus 3, minus the lower of the two functions, which is f of x, and then dx. I don't have to evaluate this. It's calculator active. You could evaluate it, but it's not asked for, so don't.